This is video 2 of looking at the topic of the standard normal distribution. And as it says right here, that standard normal distribution table that we used back in the old days before we had computers is fine as long as you're finding probabilities for the standard normal distribution, which is a distribution that has a mean of 0 and a standard deviation of 1. But how many times do we have that particular normal distribution? So the question is, how does that help us find the probabilities for the general normal distribution if x follows, and this should have an n in here, if x follows the normal distribution with a mean of mu and a variance of sigma squared, so a standard deviation of sigma. So for this type of problem, what we're going to do is we're going to transform our values that we have here, our general mean and standard deviation, into new data values that are in the z or the standard normal distribution. And we're going to do it according to this formula. So our z-score, z sub I, is going to be whatever our x score is, x sub I, minus the mean divided by the standard deviation for each data value x sub I. So that's in our regular normal distribution, this one. So it says, let's suppose that x follows a normal distribution with a mean of 20 and a variance of 4 squared, which means that the standard deviation is 4. And we're going to use the values in the table. And so for right now, it says, okay, now don't use the calculator. We'll check that at the end. And suppose we want the probability that x is between 23 and 29. So what that might look like is, if this is my normal curve, we know that the mean is 20, so we know that 20 would be right here in the middle, and we know that our standard deviation is 4. And so our standard deviation, this would be 24, one standard deviation, so this is mu plus sigma. This would be 28, would be the next one, would be mu plus 2 sigma. And then the next one after that would be 32, which would be mu plus 3 sigma. And so we would be looking for the probability that we are between 23, so somewhere down here, and 29, so somewhere like right here. So that's really the area that we're looking for. So what we're going to do is we're going to transform that really into the standard normal, like this, so that I'm going to make this more so that this is 0, the mean, so the high point is there. We're going to transform that into the standard normal. So remember, on the standard normal, mu plus sigma would be 0 plus 1, which is 1, and mu plus 2 sigma would be 2, and mu plus 3 sigma would be 3, and so forth. Okay, so we're going to use this transformation formula right here, that our z value is going to be our x value minus mu divided by sigma. So that means that our z sub 1 is going to be equal to our x sub 1, which is 23, minus the mean, which is 20, divided by the standard deviation, which is 4. And so we end up with 3/4 or 0.75. Now, if we think about that for a minute, that should make total sense, because if this is 23 right here, then this is 3/4 of the way across. This is 4, and this is going up 3, so it's 3/4 of the way. And so that should make perfect sense that that corresponds to 0.75 on the standard normal curve. All right, then we want z sub 2, so z sub 2 is going to be our upper value, 29, minus the mean. So again, I'm just using this formula. Sorry, this formula right here. Minus the mean, which is 20, divided by the standard deviation, which is 4. So we get 9/4, which of course is 2.25. And again, that should make perfect sense, because if this is 29 right here, again, this total distance is 4. We've gone 1/4 of the way between here and here. So 1/4 of the way between 2 and 3 would be 2.25. And that's the area that we want. So just like before, on the first page then, if I want the probability that 23 is less than x, which is less than 29, then what I'm going to do is actually find the probability that 0.75 is less than z, which is less than 2.25. And that we're going to find with the chart by doing the probability that z is less than 2.25 minus the probability that z is less than 0.75. And that should turn out to be, squeezing it in here, 0.9878 minus 0.7734, which is 0.2144. And you can, again, I encourage you to verify those numbers on the table. So that would be our final answer for that one. All right, so now once you verify, or once you found that, then let's check that with your calculator. So it says once you have completed the problems using the values from the table, check the original problem using norm CDF. So what that would look like, of course, is you would have normal CDF, and then we're doing between 23 and 29, so you would have 23, 29, your mean is 20, your standard deviation is 4, and you should be able to verify that that turns out to be 0.2144. Same answer. Okay? All right, so then the next piece is just a general, and this should say, by the way, the probability that x is less than x is the same as the probability that z is less than our transform value x minus mu divided by sigma. And we'll stop there and we'll do one last